Hello guys, welcome to Azure Load Balancer series. In this video, I'm going to show you how to create high available web application using Azure Load Balancer. So let's get started.
Alright, so for the purpose of this demo, I have created two web servers and I have deployed them into an availability set. Availability set basically is used to place VMs in a different fault domain and update domain. So when I created this availability set, I have two fault domains and five update domains. So for example, if I create five VMs, so VM1 will have fault domain 0, VM2 will be having fault domain 1, VM3 will be having 0, VM4 will be having 1, and then that keeps on continuing. Since I have 5 update domains, so if I create sixth VM, the sixth VM will be having 0 update domain, and seventh VM will be having first update domain. So that keeps on continuing. So when I place a VM in a different fault domain and update domain, the high availability of the web application increases. So, so I have already created two VMs and I place them in an availability set. So let's go ahead and configure my web server with a small application, IIS application. Let me open remote desktop client, put in the IP and password. So let me show you how to install IIS and let's configure a small IIS web page. So this is the server manager. I'm going to click on add roles and features and click on next, and I will select IIS from the roles and I will add the feature. Click on next and then install the IIS role. So when the installation begins, let's go to the local server and disable the IE enhanced security configuration so that when I browse, it doesn't ask for a lot of prompts for me. So I will click on this and I will turn this feature off. All right. So we will resume once this feature is installed. All right, the installation is completed. So let's go ahead and edit the default web page. So let's go to C colon, inetpub, www root. I'll go ahead and edit this HTML file. So whenever I browse, I will get web server 1 over here. So let's try to browse locally and check if it is working. So let me try to do localhost. Yeah, there you go. So whenever I try to browse this server, I'll be getting web server 1. Similarly, I have configured my web server 2. So this is the another server. So let me browse it. Whenever I try to access the server, I'll be able to get the web server 2 page. So one important thing what I just wanted to tell is this is my web server. If I try to access with a public IP address, I should be able to see web server 1. If I'm not able to see that, then there is a connectivity mismatch. So you just need to make sure that you allow port 80 in the network security group. So what I'm trying to do now is I'm going to my network security group, and in the inbound rule, I'm going to add port 80 inbound allow. So once I did this, if I try to browse it again, I should be able to see web server 1 over there. So the changes are still applying. So in the meantime, yeah, it's done. So let's try to browse it out again. So let me copy this page, browse it again. Yeah, it may take some time to reflect. So let me do a refresh over here and check if it is reflecting. Yeah, I do see a port 80 allow rule over here. And let me try to browse it again. Yeah, there you go. I'm able to browse my website. So let's go ahead and try to create a load balancer and add these VMs to the backend and check how the load distribution happening. So I will create a load balancer in East to West region. I'm gonna just choose basics queue. I'm gonna create a new public IP and create. So the load balancer creation is gonna be fast. It's not gonna take much time. Um, so once the load balancer is created, we can quickly try to add the VMs. So let me go to my dashboard. So this is my resource group. As I already told, we have two virtual machines and we have the IIS installed and web page configured. These two VMs belongs to an availability set. Now the VM, now we need to add this VM once the load balancer is created to the backend pool. So once that is done, and we need to configure a few other steps in the load balancer, then then when we try to access the load balancer public IP address, the load distribution happens. So once this is deployed, we will resume this session. All right. As you can see here, the load balancer is already deployed. So let me open the load balancer. So it's a fresh load balancer without any configuration. As you can see, it's a public based load balancer as it has a public IP address. The SKU of this load balancer is basic. It's deployed in East to West. Let's first go ahead and try to add a backend pool to this load balancer. So I'm going to click on add, type a name for the backend pool. I'm going to put as backend pool 1. So I will select. So you will be able to select the VNet in which the same region as that of the load balancer. Since I have created the load balancer in East to West, all the virtual network which is in the East to West will be listed. So this is the only VNet which I deployed in East to West in my subscription. I'm trying to associate a virtual machine and I have two virtual machines. First, I will select the first one and select the IP config. Then the next one and click on add. Once this is done, the backend pool would be successfully added. Once the backend pool is done, what next we need to go ahead and configure the health probes. So let's try to create the health probe. So we have two protocols, TCP and HTTP. So if it is in standard load balancer, standard SKU load balancer, you will get three options: TCP, HTTP, and HTTPS. Let's go ahead and so the difference between these two probes are basically TCP. If I select TCP and port 80, if there is a successful TCP handshake happening, then load balancer will consider the backend pool as healthy and it forwards a packet. If I select HTTP, then I need to specify a path in to which the load balancer forwards the request to. And the backend needs to respond with a 200 OK response. If it gets a response other than 200 OK, load balancer will consider the backend probe as unhealthy and won't forward the packet to the specific server which is responding with a non 200 response. So for this demo, I'm going to use HTTP and I'm going to go with the default path slash. I'm going to give health probe as HP name and then gonna click on OK. All right. So I think since a process is already running, I'm not able to create another one. So let me wait for this process or this operation to get completed, and then I will go ahead and create the health probe. As you can see, the health probe is successfully created. So now let's go ahead and create the load balancing rules. It still shows updated. Let me just try to refresh it again. Yeah, there you go. So I'm going to create a rule. I'm going to give it a name. So rule is basically used to bind the front end IP, the backend pool, and front end port to backend port translation, as well as to which health probe you wanted to use. So basically, the rules is a binding parameter for all the components of this load balancer, right? So I'm gonna choose IPv4 as a version, and the front end IP I just have one, and protocol is TCP. So the front end port is 80. I'm gonna translate that to port 80 to the backend pool. So for example, if my backend pool is the service is actually working on port 8080, then I can do 8080 here. So for the client, they will be accessing the load balancer with the load balancer IP and port 80, and load balancer does the translation, port translation for you to backend port 8080 and forwards that to the backend pool. So in this case, my since my web application is running on port 80, I'm gonna leave it to port 80. And the backend pool, I have two virtual machines, and the name of the backend pool is B1, which we have already created. And health probe, I'm going to use the health probe which we just created. It's HTTP and it's listening on port 80. And session persistence is the load balancing method. So if I choose none, which means it's going to use 5 tuple information of the client and for undistribute the packet. If I choose client IP, it's 2 tuple, which is source IP address and destination IP address. If I choose client IP and protocol, it's source IP, destination IP, and protocol. So based on that, we can do the load distribution. So in this case, I'm gonna leave it to none, and I'm gonna have the floating IP to disable, and I will click on OK. Once the rule is created, um, I will show you. So when we browse the load balancer IP address, few traffic hits the web server 1 and few traffic hits web server 2. So let me copy the IP address here. All right, so once the rule is created, we should be able to see the IP address displayed over here. Till then, you will not be able to see the IP address. So let's wait for the rule to be created. Once the rule is created, I can resume back and show you the IP address being displayed over here, and then I will try to browse the IP address, and I will show you the load distribution. All right, as you can see, the public IP address of the load balancer here, which gets displayed once the rule is created. Let's try to browse it. Browse the public IP of load balancer and let's see. See, I'm able to land to web server 1. So so this is another window, a new session, and as you can see, it is landing to web server 2. So the load distribution is not 50-50% or not round robin. So the load distribution happened based on the hashing algorithm. So when you consider a small sample, the load distribution may not be 50%. When you consider a very big sample, it would be kind of equal. So that's how load balancing distribution happens in load balancer. So that's what I got. I hope you guys have enjoyed this video. See you guys in the next video. Thank you.